Today we're going to make an electronic Variac. Don't think I'm going to use a Triac, because that wouldn't be a Variac, nothing like that. The one I'm going to make doesn't affect the waveform like the dimmers that use a Triac. Those who have ever wanted to buy a Variac probably hit a wall when they saw the price. They're very expensive. The one we're making today can't handle much current. At most, we'll have a maximum power of 100 watts. We're not going to wind transformers either. If you remember, a while ago I made one, but we had to wind several secondary coils. It was the 8-bit Variacs. I'll leave it in the eye if you want to check it out. It's interesting. This other one we're going to make today is purely electronic, doesn't require many components, and works quite well. Here you can see how I adjust the voltage of this lamp, which is a 100-watt filament lamp, just by turning the potentiometer. You can also see here that the waveform on the oscilloscope at the output isn't distorted. It's the same signal as at the input. That's actually one of the features of the Variac. It doesn't create a chopped waveform or generate noise. We're going to use very few components for this project. We're going to need two identical transformers from 220 to a secondary that can be between 12 and 35 volts. The important thing is that they are identical. The power will be around 100 watts. Meaning if you use 220 to 12, the secondary current should be a little over 8 amperes. In my case, I'm using larger transformers, and I'll be able to modify the original circuit to get a little more power out of the Variac. I'll explain how to do the important part. The semiconductors I'm using in this project are two TIP 3055 SABD 139 to 1N4007 diodes, two 1 ohm half-watt resistors, and two 1 ohm 5-watt resistors. For these ceramic ones, the original circuit called for 0.47 ohms, but I didn't have any, so I used these 1 ohm ones, and they work just fine. We also need a good heat sink, a really good heat sink, and a 5K potentiometer with a switch, and also a 10 amp bridge rectifier. You can use these table type ones, or you can use 10 amp diodes. Assembling the board is super quick. There's no secret to it. Here in the description, I'm leaving the Gerber file so you can order the boards from JLC PCB, and you can also assemble it spider style if you don't want to order the boards. Since the number of components isn't very large either, you can also do it directly in the air. The important thing is to use a really big heatsink, since this works like a linear power supply. So the voltage drop we create in the Variac has to be absorbed by the power transistors. And of course they heat up. If you want more power, you can replace the TIP 3055 with two MJ-15003. Without doing anything else, just by making that change, simply swapping the big transistors for the MJ ones, you'll have more available power. As long as, of course, the rectifier bridge and the transformers are supplied by the Variac. It's not the best in terms of efficiency, as you can see, but it has its advantages. Since it doesn't distort the sine wave, it doesn't introduce noise like Triacs do when they cut the wave, let's say, and it's also an isolation transformer. Well, if my friend Gaston from Proyecto LED sees the video, I'm sure he'll give me a hard time. Since in terms of energy, it's very inefficient. That's because, well, let's agree that a lot of energy is wasted when we lower the voltage and the transistors absorb it. This is the schematic of the project. It's very simple. As you can see, the potentiometer varies the consumption of the power transistors, and it does this through the VD, 139, which is the smallest transistor here. This one doesn't require any kind of heatsink. It's highly recommended to put a 600 milliamp fuse at the input of the transformer, where the 220 volts from the line come in, to prevent the transistors from burning out. If we're tempted to put a load of more than 100 watts, then the fuse blows and we save the transistors. Illustrate this video a bit more. I'm going to show you images from a thermal camera so you can get an idea of how it works. And the voltage we lower at the output is absorbed by the transistors, meaning the more we lower the voltage, the hotter the output transistors will get. So, well, you can also add a small fan, a 12-volt cooler, taking power directly from the input transformer output and regulating it with a 78.2 that will also help relieve the transistors a bit. I'm preparing a heatsink with 2 MJ transistors that can handle more current, and I'm also going to add a voltmeter to the case to know what voltage is coming out. Well, before finishing the video, I want to thank 2 friends who are always contributing to my electronics projects. Fabian, also known as 2050. Here on the channel, you can always see his comments. He was the one who sent me the schematic for this interesting Variac. And also to Angel de la Plata, also known as Black Teaser, with whom we've already done a lot of projects before, since back when I was on the Amateur Scientists Forum. A great friend who knows a lot and is always helping me with circuit interpretation. Thank you both very much. Well, I hope you enjoyed the video. Please give it a like, share it on your social networks, and subscribe by clicking the bell. Receive notifications when I upload new content. You can join, and in that case, I will add you to a WhatsApp group where the premium members are. Thank you so much for watching the video, and until next time, God willing.